Hi, welcome to section 7.1 and 7.2. We're going to do them together. Why? So we can save you some time because you're a little bit behind and I know you don't want to spend all of your Christmas trying to catch up. So, and I apologize, Isaac, if you didn't get behind, I'm sure you will go just as fast as you're supposed to. Your sister, she has to have everything just so. And I bet you're not quite that way, but it's okay. Either way, I can work with it. Okay, so besides, I've had some days off and relaxed, and been calm and been sick, and all sorts of things have been going on with me. Not that you asked for any of that. I mean, realistically, you can care less. I know. It's okay. It's okay. I'm coping. I'm gonna be okay. I have overcome and I have gotten myself together. And by now you should have everything exactly where it is supposed to be, including your book, because we're going to look at your book a little bit during chapter 7. So make sure you always have your book right there handy. I know you've already done the highlighting, but you don't get to put the book after you do the highlighting, because you know you got to do the classwork and stuff. So just make sure you can grab it and look at it. That keeps me from having to do a whole bunch of drawing up here. So section 7.1 and 7.2 is taking what you've learned in algebra and pulling it just a little bit further out before we start really using it in geometry, and we will really use it in geometry. So we start by talking about ratios, which I know you know about because I was there. Hello. Yes, I don't know if you remember them or not. So I have to give you the whole algebra background so that I can throw the geometry stuff in there. So the algebra background is that ratios can be written in 3 different ways. You can say x to y, or x to y with a colon, or x to y with a fraction. And since you have this whole fraction thing, you need to remember that ratios always need to be reduced. Even if they're written this way, since it is a ratio, it can be reduced, and you should do that. Now, they're going to start giving you ratios and expect you to be able to use them in problems. That's what I'm here for, to help you with some of that. So, the first example I wanted to go over was finding the measure of an angle, finding the measure of the angles of a triangle when the angles of that triangle have this particular ratio. And this problem came exactly right out of your book. It might even be example 1. But I chose this one because I need you to be able to say, oh, if they're giving me this, this is how I apply this to something I already know. We already know about the angles of a triangle. One of the things that we know about them is that all the angles of a triangle have to add up to 180. Hope you remember that. If not, you're going to have to go back and memorize some stuff. So since we know that's the truth, and since we know that this is a ratio for my angles, I can say 3 times some number plus 5 times that same number plus 7 times that same number has to equal 180. Now here's the thing. A ratio basically works like this. If I multiply the same number by each of those, I get the same ratio. That's what makes them reducible. So that being the case, if we know that all the angles of the triangle have this ratio, we don't know what it is that we're supposed to multiply them by. That's where the x's come in. But we do know that it has to be that 3 times some number and 5 times that same number and 7 times that same number has to be my sides. Now, like I said, we don't know what the x is, but we can figure out the x because I got an equation out of it. So now that I have an equation, all I have to do is solve my equation. 3 plus 5 is 8 plus 7 is 15x. Has to equal 180. Divide both sides by 15. X must equal 12. This is not your answer. So since x is equal to 12, they wanted to know the measure of the angles. So I know one of the angles is 3x, which is 3 times 12, which is 36. One of the measures is 5x, which is 5 times 12, which is 60. And then the other measure is 7x, which is 7 times 12, which is 84. So my three measures are really those three. Make sure you always take it back to where you're supposed to be asked for, which was this. That's the algebra end of it. We applied it to some geometry here because they told you the measures of the triangle. Okay, so we're pulling a little bit of the algebra into the geometry. Over here, we start talking about proportions. We have to do a little introduction with ratios before we can get to proportions, because proportions are two ratios that are equal. Now, these two ratios that are equal, if they were to be reduced, you'd get the same number on both sides. But usually they're not reduced, and usually it doesn't really help you to go ahead and reduce them. But we'll talk more about that in a minute. Currently, what I need to talk to you about is things called means and extremes. And I talked to you a little bit about this in the video. These two right here are your means, and these two right here are your extremes. Your extremes are where you begin and you end. Your means are how you get from the beginning to the end. Okay? So now that you know that, you have to understand that the product of the means must equal the product of the extremes. That's one of the facts that you have to get. And I promise you, I scoured your book. It's not in there. They expect you to already know this from algebra, which is fine. Why are they going to go to the trouble of not telling you some things that you're supposed to know from algebra, but telling you other things? I don't know. He's expect you to have a pro teacher. Him, you. So in order to do this problem, you have to understand that fact. We'll get back to the means and the extremes in a minute. This fact is using something called cross products. Your book uses that a lot. The cross product is what you get when you multiply either your means or your extremes. So down here, when I start to solve a proportion, I can say that 6 times 10 is equal to 15 times x. Now, there is nothing that says that you have to do it this way, okay? But Miss Rogers tends to always put the extremes on the left-hand side and the means on the right-hand side. And the reason she does that is because there is a trick that I used in algebra when we were trying to figure out which one was best, which one was less than the other or greater than the other. And that's how you always did it. You multiplied these two and it went on this side, and you multiplied those two and it went on that side. So it's a throwback from there. I always do it. You don't have to do it that way. The truth of the matter is, as long as they're equal, it doesn't matter. So when I multiply 6 times 10, I get my 60, and my 15 times x is 15x. Divide both sides by 15, and you get that x is equal to 4, which really is your answer, because that's what we were looking for with the x. They didn't tell us anything else to look for. Now, since 4 is my answer, what this really would become, if I were to rewrite this proportion, would be 6 over 4 is equal to 15 over 10. Now, I need you to understand, I have finished this problem. There is nothing else to do. I just want to point something out to you, that's all. That's all I'm doing now, is pointing something out to you. If I were to reduce this side over here, I get, oops, I don't get a 2. Gosh, Joanne, that's better. I get 3 over 2. And if I were to reduce this side over here, I would get 3 over 2, which we know is equal. I'm just saying that has to always happen because it's a proportion. That's what proportions do. They always do that. So if you kind of know that, and you don't really want to use the great big numbers, you can always reduce them down. When you very first start doing this stuff in algebra, sometimes, or even in elementary school, sometimes they have you start by reducing it down to see what it is, which always used to frustrate me because I'd rather just teach you the stuff you're going to have to do later. But neither here nor there. They start with having you reduce both sides so that you understand that. So it might be that you already know this, but think of it as refresher. It's okay. All right, now we need to talk about a couple of other things. I told you that whenever you tell me a ratio, it always needs to be reduced. That's true. Already wrote that down, so I'm happy with that. But some of the things that they don't tell you, actually they do tell you, it's in the next section, it's in 7.2. Is that just because it's written this way doesn't mean that it has to stay this way. So if I have this proportion and I wanted to rewrite it, I could rewrite it like A over C is equal to B over D, because that's a true proportion too. It's a true statement, true proportion. You can write it that way. It's not going to change anything. It's not going to affect anything. All we did was switch our B's and our C's. You can switch the means out. You could also switch the extremes out. So I could say that D over B is equal to C over A by flipping those two. I can do that because it's not going to change my cross product. That's the important thing. As long as it doesn't change the cross product, you're cool. So here I would still have A times B, just like I had A times D there. Here I still have C times B, just like I had C times B there. Doesn't matter which one comes first. You got commutative property for that. So since the cross products stay the same, we're all good. We could also switch around the fraction itself. So I could put my denominator on the top on both sides, and I still have the same cross products. I still have the B times C and the A times D. My means changed, my extremes changed, but because the means stayed with the means and the extremes stayed with the extremes, our cross products have to be the same. So that works. And then you can flip them around. You could say C over A is equal to C over B. Still gives you the same cross product. Same stuff. Or we could say B over D is equal to A over C. Same cross product. As long as you don't mess with those cross products, you're okay. That's the big takeaway. Now, all of that to say this, when we're looking at figures in the future, and I set up my proportion one way and you set up your proportion a different way, it doesn't mean that your way is wrong. Because if I set up my proportion my way and I choose that and you choose this, we're all okay. Everything's fine if we go this way. Just like everything would be fine if I choose that one and you choose this one, because it's all the same stuff. It doesn't have to be set up the same way. It's okay. You're still going to get the same answer in the end. So you need to kind of understand that as long as your cross product stays the same, we're all good. Now, the hard thing is making sure that you're setting it up right. I'll tell you some tricks when we get there to having set these up. But generally speaking, I try to put the small figure on top and the large figure on the bottom. I usually don't do the same figure on the same side because that's what it all boils down to. You can either have the small on top and big on bottom, or you can split them up in fractions and say small on this side and large on this side. Either way, you're going to get the same stuff, but these are the two general ways that you split stuff up. You either put the small figure on top and the big figure on the bottom, or you put the small figure all on one side and the big figure all on the other side. But corresponding sides, as long as they're good, you're good. So it's not nearly as difficult as you may want it to be, but it'll be okay. We'll get through this. Okay, so that takes care of all of 7.1 and most of 7.2. There's just a couple more things I need to talk to you about in 7.2. So give me just one. And okay, so we need to talk about something called the geometric mean, because we'll use this later on. Probably in around chapter 9, I'm guessing. That's usually when things like this pop up, around 9, 10. And I know 10 is construction, so it must be around 9 or 11. Geometric mean between any two numbers, doesn't matter what the numbers are. This is the way you find it. You set up your proportion where A, that's the first number they gave you, is in the first spot, and B, that's the second number they gave you, is in the second spot. The geometric mean between those two numbers would be whatever goes in these spots, which has to be the same number. So in this case, I'm going to put X there. Now, can't really solve that one, but even you can see that means that A times B has to equal X squared, which helps you do things a little faster. But being able to set it up into the proportion is actually beneficial. So don't just jump to the X squared part. Go ahead and show the proportion because that'll help you later on when we get to the other stuff. Okay, so when we're doing problem number 11, which is on page 269, I say that because I'm going to point to the next one, which is also on page 269. They want you to find the geometric mean of 5 and 8. If you want to pause it and give yourself a second to see if you can do it by yourself, that's fine. I'll give you a second. Go ahead. Okay, so in order to find the geometric mean of 5 and 8, 5 would have to be my first number. 8 is my last number. And I'm looking for the stuff that's in between. So that means that 40 has to equal X squared. And then we just take the square root of both sides. That gives me the square root of 40 is equal to X. But we don't know the square root of 40, so we're going to have to solve it. Don't get angry at me because you don't really remember how to simplify square roots. You know, you have 2 on the inside, it equals 1 on the outside kind of thing. Remember that? So this is 2 times 2 times 2 times 5. 2 2's on the inside, make 1 on the outside. So that gives me 2 square roots of 10. That's a 10. Is equal to X. Because I went down somewhere. So that is how you, gosh, that looks horrible. Hold on, I can make that better. Watch this. 2 square roots of 10 is equal to X. I don't have to go down so low. Okay. Now, one of the things that kind of bothered me about this particular section is that I kept waiting for them to say this one fact, and they never wanted to say it. And I guess it's because they've said it in the past, and I just happen to know it. So I can't remember if you know it or not, but what I do know about you is that chances are, if you knew it, it's probably out of there by now. You spent so much time away from math and not focusing on memorizing all of those postulates and stuff, which you're going to have to go back and start rereading because midterms are coming and they go from the beginning to now. So just word of warning. So you might want to look back, but I hated not having it there, so I went ahead and wrote it for you so that you can kind of get the gist of what they're using. So they don't say it, but it's true that when lines are parallel, the segments in between them are proportional. Now, they never said, this is on page 269 at the bottom, they never said that these were parallel lines. They didn't say that, but they did go to the trouble below that of writing this proportion that's true, which told me those must be parallel lines. Now, I knew that it told me that. I needed to make sure it told you that. So that's why I threw this in there so that you know that, oh, these must be parallel lines. I mean, they look parallel. Well, not on my drawing, but in the book, they look parallel. So that's all good. But there's a proof behind it that's true also because of the fact. And we will use that fact in this chapter. They wanted us to use this fact and that pretty picture to fill in what's missing for number 15. So in order to fill in what's missing, let me go ahead and get the stuff that's down here that I can put up here. And since I don't have to worry about whether or not I write in the book kind of thing, because that's already up here. I can just erase the thing and put it up there. So they didn't tell me JK, so I'm looking for it. They didn't tell me KL. They didn't tell me PN. They didn't tell me NM. They did tell me KN. So I'm going to take out KN and put what they told me. That's a 2. And I'm going to take out LM and put what they told me. That's a 9. Okay. That's going to make this a little bit difficult. Basically, if I look at JK, that's this segment right here, and KL, that's this segment right there, I know that JK and KL have to add up to JL. So this one plus that one has to equal 22. So if I were to let this one be X, that would mean that one would have to be 22 minus X. It's something. I'm not sure what just happened, and if you saw that or not. So just for a second, because I'm also not sure when it happened, but just for a second, since I know that JK and KL add up to JL, that means that if I let this be X, that one has to be 22 minus X, because that's what JL was, minus that little part would give me that little part. That's back from algebra stuff. So I can go ahead and take that and replace it down here. So instead of my JK, I can put my X, and instead of my KL, I can put 22 minus X. Now I could go ahead and do Y and 33 minus Y. In fact, I think I will. I'm going to go ahead and call this one Y, because we don't know it. And that makes this one 33 minus Y is what I have left. So I could replace them up here. So I have y and 33 minus y. But when I go to solve this proportion has 3 fractions in it. And you can only solve a proportion that has 2 fractions in it. So I need to make sure I pick 2 fractions. And one of the fractions I need to pick needs to be one of the ones that's complete. So I'm going to set up 2 different problems. I'm going to have my x over 22 minus x is equal to 2 over 9. And then as a separate problem, I'm going to have my y over 33 minus y is equal to 2 over 9. When I do my cross multiplying over here, I get my 9x is equal to 22 times 2 is 44 minus x times 2, because you got the whole distributive property, is 2x. Adding 2x to both sides, I get 11x is equal to 44. So x must be 4. Since I know that x is 4, I can come back and say, oh, x was this one. See, JK, x. So this is my 4. And this one is 22 minus 4, which is big number, 18. Okay. So over here, do the same cross multiplying. 9y is equal to 2 times 33 is 66 minus 2y. Add 2y to both sides. 11y is equal to 66. So y must be equal to 6. Y was Pn, so that one is 6. And 33 minus 6 is 27. Now, if I wanted to, I could replace these with the appropriate numbers, and then I could reduce them all down, and you will always get the 2 over 9. Ta-da! Simple and easy enough. Which leads us to your classwork and homework for this section. And I know it's been a long video. Don't blame me because it's been a long video. I did group 2 sections together so you could finish things faster, and I'm saying you're probably done with classical conversations by now. So, because I grouped 2 different sections, that means your homework and classwork are on 2 different pages. So, for the classwork, you have page 265, numbers 4, 12, and 16, and then page 269, numbers 9 and 14. And then for the homework, on page 265, you have numbers 6, 14, and 20. And then on page 269, you have numbers 12 and 16. And I will see you, I don't know when I'm going to see you. I hope you see me tomorrow. But if you don't, I get it. As long as you finish chapter 7 before you go on your Christmas break from me, we're all good. So, well, as long as you finish that midterm anyway. So hopefully you will see me tomorrow. Bye.